Alright guys, welcome back. This video is going to be a bit of a review on X and Y intercepts, and then I'm also going to show you how you can use Desmos to do the calculations for you to get you those values. Alright, so finding an intercept, remember intercepts are where the function crosses the X or Y axis. So we are looking for those locations where either the X value is equal to 0 and we are crossing the y-axis, or the y value is 0 and we're crossing the y-axis. Okay, so just remember it's the opposite. So if we're going to find the x-intercept, we still need to do these steps. So you still need to factor, you still need to cancel out your holes. Okay, and then if we are looking for the x-intercept, that means our y value is 0. Okay, and remember that y is the same thing as f of x. So what we're essentially saying down here in our example is this f of x has to equal 0. Okay, this whole function is going to equal 0. And we know for fractions, anytime the numerator equals 0, like 0 over 1 is 0, 0 over 2 is 0, 0 over 10 is 0. Okay, so as long as we have this numerator equal to 0, the whole fraction is going to be equal to 0. And so we will take our numerator and set it equal to 0, which tells me x equals 4. And so this is where my graph is going to cross the x-axis on x equals 4. Right? Remember, just like we talked about before, these are also called roots, zeros, solutions, um, and zeros. Okay, so if I come over here, I would go over to where x is 4, so 1, 2, 3, 4, and I would place a point on my graph. Okay, this one was pretty easy because it wasn't super, there wasn't a whole lot of math to do. So on this case, my x-intercept is 4, 0. I go to the right 4 and up or down 0. Just make sure that you are following directions. If they ask for the x coordinate, you would only write 4. If they ask for the x-intercept, you would put 4 comma 0. So it can be written in both ways depending on which who's asking the question. Okay, and then we're going to look at the y-intercept. Same idea, right? Y-intercept, we're crossing the y-axis, which means we start at the origin, we're not moving left or right. So in this case, my x is 0. So instead of setting my equation equal to 0 and using the numerator, I'm going to substitute. So all of my x's are going to now become zeros, and then we would simplify. Again, you still need to factor and cancel out any holes first, because if you don't, you'll get 0 over 0, and then your calculator is going to give you an error and your graph won't show up. Okay, so you want to make sure that you do those steps first. That's why we factor and find those holes first. Get them out of the way, and then we can work with what's left. Okay, so for this example, we have x minus 4 over x plus 4. So what we are doing, if we are substituting 0 for x, is we are asking what is the value of our function when x equals 0, or what is f of 0. So you can do this by hand. This one is very simple because we have x minus 4, the numerator would be 0 minus 4. And if we have x plus 4, the denominator would be 0 plus 4. And then we're just going to simplify. 0 minus 4 is a negative 4. 0 plus 4 is 4. And then negative 4 divided by 4 equals negative 1. So in this case, I have a y-intercept at negative 1. So I would go to my graph and go down 1. Okay, and then the coordinates for this one would be 0, comma, negative 1. Or if they just asked for the y value, you would say negative 1. Okay, if you wanted to do that in Desmos, then you would type in your function f of x equals, okay, I'm going to set up my fraction first just because then I don't have to worry about quantities being in the wrong place. We have x minus 4 in the numerator, and we have x plus 4 in the denominator, okay? On the next line, I'm looking for f of 0, so I'm going to type f of 0, f with the 0 in parentheses, and then you can see right here on my screen, it gives me the answer of -1. Okay, so that I know that. We could use this over here as well, okay? If it tells us that we need x minus 4 divided by x plus 4, and I need my entire function to equal 0, I can see that by just setting the numerator equal to 0. Sorry, I did an extra step there. We get this green line that tells us x equals 4. You should still show the algebra, but if you want to use Desmos to double check when we get into these longer, more complicated polynomials with higher degrees, you can definitely use Desmos to double check. Okay. All right, let's look at another example. Okay, this is the example that we factored previously. So we have 2x plus 1, and then x minus 1, all divided by x minus 4 over x plus 3. Okay, and this was the same problem that we did before. And now we're going to do the same thing, okay? So we factored it. We don't have any holes. If we did, we would cancel those out and use what we have left, just like we did in previous problems. And then we're going to try to see if we have an x-intercept and a y-intercept, okay? X-intercept means that our y value is 0. Now we have two different factors. So remember, if either one of those is 0, it doesn't matter what the other one is because 0 times anything is still 0. So we have to do both of these because that means that we have two possible answers. So 2x plus 1 equals 0. Subtract your 1, you get 2x equals -1, and then x equals a -1/2. And then we will do the other factor also. We have x minus 1 equals 0, so x equals 1. So this tells me I have two intercepts. I have one of them at -1/2. I'm going to have to estimate because my graph is really small. And the other one is at x plus 1. And then I'm going to write my points down here for clarity. Okay. Okay, and then the y-intercept. Remember, this one is where if we are on the y-axis, that means our x is 0. We're not moving left or right. So we are just going to substitute. Okay, and I'll show you both ways again. So we would say 2 times 0 plus 1. Actually, I might do it up. Let's see. Let me see if I can color code it, guys, and make it a little easier. Okay, 2 times 0. So we are substituting 0 in for all of our x's. Okay, so if we make that a 0, then when we come down here, 2 times 0 is just 0. So in this first set of parentheses, we're going to have 0 plus 1. In the second set of parentheses, we're going to have 0 minus 1. And then do the denominator. X minus 4 becomes 0 minus 4, and x plus 3 becomes 0 plus 3. Okay, and then we can simplify. So 0 plus 1 is 1, and 0 minus 1 is a -1. 0 minus 4 is a -4, and 0 plus 3 is 3. And then 1 times a -1 is -1, and -4 times 3 is a -12. And then this is going to simplify to a positive 1/12, okay, which means it is pretty much on the y-axis, 1/12. If you divide that first unit into 12 parts, we're only going to go up 1. And then my y-intercept, my x value is 0. My y value is 1/12. Okay, if we want to do that in Desmos, we can go back over here. and I can type in, I have to use a different equation now. I already have f of x in there, so I'm going to use g of x so that it doesn't get confused when I substitute in my 0. Okay, and I'm going to type in 2x plus 1 times the quantity x minus 1. I forgot to set up my parentheses, guys. This is what I was talking about. If I just hit divide here, it will do the whole thing. Good. Okay, then we can do x minus 4 and x plus 3. So there's my function. Okay, and then on the next line, it's g of x. So I'm just going to tell it that I want it to find g of 0 for me. And it gives me this 0.083333 decimal. And remember, you've got this fraction tool, and it will put it into a fraction for you. Okay. All right, guys. Next lesson is the last lesson for the unit. I'll see you in that video.